Hello everyone, and welcome back to the Layman's Language channel. According to Rolls-Royce, the Rolls-Royce Trent XWB, which is the primary engine option for the Airbus A350, can produce up to 97,000 pounds of thrust. In today's video, we're going to take a look at the insane amount of power behind these Trent engines and put it into context as to what the whole pound thrust thingy is about. So sit back, relax, and let us rest the whole power thrust on your hands. Of course, in a layman's language. Don't forget to subscribe and hit the notification bell. It's going to help you a lot in managing 97,000 pounds of thrust. Have you ever wondered how much power it takes to lift a massive Airbus A350 off the ground? Well, hold on to your seats because we're about to blow your mind. The Trent XWB engines used in the planes comes in 3 variants: the Trent XWB-84, Trent XWB-87, and Trent XWB-97. The number in each variant refers to the engine's maximum thrust rating in thousands of pounds, with the Trent XWB-84 being the least powerful and the Trent XWB-97 being the most powerful. The power output of the Rolls-Royce Trent XWB engine on the A350 is equivalent to that of a small rocket. That's right, we're talking about rocket-level power here, people. A single Trent XWB-97 engine on an Airbus A350 can produce the same amount of thrust as 28 Bugatti Veyron supercars, which have a combined horsepower of 24,000, compared to the engine's 5,000 horsepower. The A350 has 2 of these bad boys powering it through the skies, so it begs the question, what is a pound thrust? Pound thrust is a unit of measurement for thrust, which is the force that propels an object forward. Specifically, 1 pound of thrust is equal to the force required to accelerate 1 pound of mass at a rate of 1 foot per second squared. In the context of aircraft engines, thrust is typically measured in thousands or tens of thousands of pounds, as the amount of force required to propel a large airplane is much greater than 1 pound. For example, the Rolls-Royce Trent XWB-97 engine used on the Airbus A350 can produce up to 97,000 pounds of thrust, which is equivalent to the force required to accelerate almost 100,000 pounds of mass at a rate of 1 foot per second squared. A typical commercial airliner like the Airbus A320 has a maximum takeoff weight of around 170,000 to 180,000 pounds. The thrust produced by a single Trent XWB-97 engine is equivalent to over half of the weight of the entire airplane. This simply means that the thrust produced by the twin engines in A350 are equivalent to more than the maximum takeoff weight of an Airbus A320. But these bad boys don't come cheap, folks. With over 20,000 components, hundreds of nuts and bolts, diameter of 118 inches, a length of 230 inches, and what appears to be miles of safety wire, the engines come in at an impressive $35 million price tag. This is as much as it would cost to purchase 100 Cessna 172 Skyhawk planes, whose market price is around $35,000. In terms of weight, the engine alone weighs around 15,000 pounds or 6,804 kilograms. When you include the weight of the nacelle, the structure that surrounds the engine and attaches it to the wing, the weight can increase to around 21,000 pounds, 9,525 kilograms. Despite its size and weight, the Trent XWB-97 is designed to be highly efficient, with a thrust-to-weight ratio of around 6:1. This means that the engine is capable of producing 6 times its own weight in thrust, which is an impressive feat of engineering. The engine features advanced technology such as an 8-stage high-pressure compressor and a 6-stage low-pressure turbine. It also uses lightweight materials such as carbon fiber and titanium to reduce weight and improve fuel efficiency. Overall, it is an engineering marvel designed to be quieter than previous generations, with a 65% reduction in noise compared to the Trent 700 engine used on the Airbus A350. The Trent XWB-97 is designed to be more fuel efficient than previous generations of engines, with a 25% reduction in fuel burn compared to similar engines. This makes it more environmentally friendly and cost-effective to operate. Thank you for watching our video. Please make sure to subscribe to Layman's Language channel and hit the notification bell so that you don't miss out on our much more exciting upcoming videos. See you on the next one!